Okay, this is where things get really tricky. Just back actually to the last question, just to reiterate a point. We said find the equation of the line of intersection. Well, I did that. But the question might say, give your answer in Cartesian form, give it in parametric form, give it in vector form. Please make sure that you're able to convert between those, okay, so that you can give the right answer. This question might have easily said, find the equation of the line of intersection in Cartesian form. It's pretty easy, just rearrange to make lambda the subject of each of the three expressions and then equate them. Anyway, okay, so now is where it's getting really, really nasty. Okay, this is what happens if we've got three planes. Okay, now if we've got three planes, there's all types of variations of what could be going on. Okay, they could all be actually the same plane. Two of them could be the same plane and the other one is not, and it's intersecting. Okay, or two of them could be the same plane and the third one is parallel. So that covers off your first two. And I hope it would be easy to identify if you had that situation, okay? Now you might have two parallel planes and then one plane that cuts across both of them. You might have all planes being parallel to each other. Certainly three parallel planes, I hope that would be easy to identify. Now they all might meet at one single point. All the planes meet at a single point, okay? Or they might all meet at a common line, such as here, okay? So they don't meet at a single point, they all meet at a single line, okay? Or they all sort of intersect each other in a sort of triangular way, okay? So the line of intersection of any two is parallel to the third. So these lines of intersection are all parallel to each other. That would be the final option, okay? So what you might need to be able to do, you might be saying, here are three planes, and you've got to be able to find out what's happening, what sort of geometric representation is actually going on, okay? So let's have a look here, okay? We're going to solve the following systems of linear equations, and in each case, we're going to give a geometric interpretation of the system. So the first thing I'm going to do, I'm going to just check to see I'm just looking at part A. Are there any parallel planes? Okay, so we've got 1, 3, minus 1 would be the normal vector of the first plane. 2, 1, 1 would be the second plane. And 1, minus 1, minus 2. So are we seeing that there are any planes that are parallel to each other? I don't think we're finding the direction of each of those is the same at all. So none of those planes are parallel to each other. So that rules out this one. It actually rules out this one. It rules out this one. It rules out this one. It rules out this one. So really, it's got to be, I think, this, or this. Okay, so let's try and find out now exactly what is going on. Well, let's equate, see if we can find a solution to the intersection. Okay, so we've got x plus 3y minus z equals 15. 2x plus y plus z equals 7. X minus y minus 2z equals 0. Equation 1, equation 2, equation 3. Let's write this more neatly. Now, can I do any elimination here? Yeah, I can. If I do 1 plus 2, I will eliminate z's. So I'll get 3x plus 4y is equal to 22. What I can also do is I can change equation 2 to 4x plus 2y plus 2z equals 14, and now I've got x minus y minus 2z equals 0. So I can eliminate z's again, by, again, adding the two equations. So I'm going to get 5x plus y is equal to 14. So this is equation 4 and 5, which I can now solve. How am I going to do that? I'm going to change 5 to 20x plus 4y equals 4 lots of 14, which is 56. And then 3x plus 4y equals 22. So subtract, I'm going to get 17x is equal to 34. So x is equal to 2. If x is equal to 2, let's sub that back in. I think that we'll see that that's what, y is equal to 4. And now sub in again. We've got here 2 minus 4 minus 2z equals 0. So negative 2 minus 2z equals 0. Minus 2z equals 2. Z must be equal to negative 1. So this system of equations had a solution, which means that all three planes must be meeting at a single point, okay? And this is the point at which they meet, 2, 4, minus 1, okay? Hope that makes sense. Now, let's have a look at B. Again, let's check whether we've got anything that any parallelness to these three planes. So I've got 2 minus 1, 1. I've got 1, 1 minus 1. And I've got 3 minus 3, 3. Have I got anything that makes these parallel? I don't believe that I do, actually. I'm intrigued by this one and this one. It looks like we might be. If I multiply this one by 3, doesn't quite work, does it? It certainly doesn't work with the other one. So again, we've got nothing there that is parallel whatsoever. Okay, no parallel planes. So again, let's try and solve. So 2x minus y plus z equals 5. Got x plus y minus z equals 2, and 3x minus 3y plus 3z equals 8. So it's equation 1, 2, and 3. Again, let's add equations 1 and 2. We are going to get 3x, well, the y's will disappear actually, and so will the z's. So that's going to be equal to, should I be adding them? Yeah. That's going to be equal to 5 plus 2 is 7. So x is going to be equal to 7 over 3. So now I can say 7 over 3 is equal to, plus y minus z is equal to 2. And 7 minus 3y plus 3z is equal to 8. So y minus z is equal to 2 minus 7 over 3. That's negative a third. Okay, and negative 3y plus 3z is equal to 1. You can see what's happening here, right? If I divide both sides by negative 3, I've got y minus z equals minus 1 over 3. And they are actually the same equation. So there's going to be infinitely many solutions. Okay? Infinitely many solutions would imply that we've got this situation. They're all meeting at a line. Okay? And how would you find out the equation of that line? Well, the same video. Just pick two of the planes and find out where that line of intersection is as per the previous video. Okay. Now, if you got a situation where you got no solutions, because remember you can have unique solution, infinite solutions, okay, or you could have no solution. Well, that would be the case if you had nothing, no parallelness to your planes and no solution from trying to solve the equations. Then it must be the case that it looks like this. Okay, so I hope that makes sense. Okay, so we know that the first one had planes intersecting at a point, and this one had all planes intersecting at a a line. And the question might now ask us to go and find out what the equation of said line is. Okay.